Hello and welcome to another video. Today I'm going to be showing you how to do the 1-0 knapsack problem. So what is the knapsack problem? So say you wanted to rob an old lady or something like that. What you'd want to do is when you're robbing them, you want to get the max value that you can carry. So so right now, this example, we're going to be only carrying 6 kilograms, which is not a lot, but we want to be like mobile while we're robbing. We're running away from the cops after this or something like that. And right now we have 4 items, and the value, this will be in like dollars or something like that. And what we want to do is at the end, at the full weight 6, we want to have the highest possible value. Okay, and we do this by creating a matrix, and we divide it into subproblems, and we solve each one until we get to the end. So the problems we're going to do is so this will be like item 1, that's this one, and we'll see the max value we can get if our backpack only contains item 1 and has a weight of 1. And then we'll do the same thing with only item 1 with a weight of 2 this time, and then so on. And then after that we'll go to item 2, and we'll see the max if our backpack can have items 1 and 2 at the weight of 1, if it has items 1 and 2 at the weight of 2, and so on, and we'll solve each one until we get to the end of the matrix. So let's do this real quick. So we start off at item 1, and first thing we check is we can actually fit it in the bag. So we check the weight, and if it's greater than the weight, we don't do anything. So what we're actually doing is going from the matrix above, but I didn't actually draw a 0, 1, but we should do that. So same thing for here, and then we get to weight 3. Well, we can put that in the backpack, and we can put it in with a weight of 7, and it'll go for 7 for the rest of them, but we'll check for each one. Okay, so item 2, we have a weight of 1 and a value of 2, so let's go to that. So what we're checking is if the value is greater than the one above it, and if it's greater than the one above it, we'll put it in the backpack. So let's do that. We have 2, 2, and this one, it's 7's greater, so we're going to put 7 there. But we're not actually doing just item 1. We got to check if item 1 and 2 is possible. And how we do that, okay, so remember we're breaking it into like its own problem. So we got items 1 and 2 at weight 4. Now if we just add item 2, what we actually have is we take out 1 weight, and we're left with a weight 3 remaining. And what we want to do is check the best value we have at weight 3. We add that to our item 2 and see if that one's any bigger. So we have weight 1, so we put that in the backpack. We move up 1 because we're not doing duplicates, and we move 1 weight to the left and find the value right here that we put in the backpack. So we take this value, add it to the value at weight, our item 2, and we get 9. And 9 is greater than 7, so we throw in a 9. So this is probably the most complicated part, so I'm going to explain it one more time. So we're at weight 5 with items 1 and 2, and we want to see the best way of doing it. So we take our value, or our weight, we go up 1, we subtract it by the weight, and this gives us item 7, or value 7. We add that to weight 2, and we compare it to the one above it, and it's greater, so we put it in. So we put the max of those two. So just a quick thing to note, see here we kept it the same from the bottom, so that's us not adding in the item. So I'm just going to do it real quick, and hopefully it'll make a bit of sense. So I'm just going to finish it off. Okay, so that is the full matrix. You want to maybe like try one yourself to see if it makes sense, but that's all I'm going to do for the explanation part. Let's get to the code. Okay, so I've already started off a bit, so I already made a function and I just populated a blank matrix. We have the item weights, the values, and I put that in an item that's a list of lists, and our max weight will be 6. So okay, so let's get our matrix going. So we're going to need 2 nested for loops. So we're going to start with row in range items, just use the weight, doesn't really matter. And then we're going to need the item or the column, so all in range max weight. Okay, so remember the first thing we checked if we can fit it in the bag. So if so we're going to check the weight of the item. So items 0 was weight, and we're going to check at the row. If that is greater than column, what we're going to do is set it to the one above the matrix. So matrix at row column will be same thing, just minus 1 to the row. Okay, so the else, just copy and paste this. So remember, we compared to the one above it, and to the left, the weight we're using, and we compare that to the one above it. So it's going to be the max of, this is the first one, and the second one, what was it? So matrix at row minus 1, and our column will take the weight and we'll minus the weight of the item we're working with. So items at the weight at row, and after all this is done, we'll add the value to that. So I'm going to plus items at 1, we're grabbing the values, and at row. Okay, and that's all we have to do to populate our matrix. So for I in range, I'm just going to print this out. Print matrix at I. Didn't really work, did it? One maybe. Off by 1 error. Okay. And if you remember, this is exactly what we got in the visual version. So that's how we do it now. This just shows us the max weight, but we actually got to know which items are going in the bag. We don't just want to know the max weight, so we'll do that right now. We're going to try and figure out which items are going to go in the bag. So what we're going to do is we're going to set pointers to the bottom right. So item 4, weight 6 in this case. And we'll check that one, and what we do is we look above it and we check if it's the same. Now if it's the same, that means item 4 did not affect the final value of what goes in the bag. So we can actually just cross out and we don't have to care about it. And we're still pointing on our max weight, but now we're on item 3. We go one above, 9. That's different. So that's going to go into the bag in the final thing. So let's add item 3, cross it out. And now what we got to do is solve the best with the remaining items and the remaining weight. So first we got to do is move up to item 2. But we're not checking the max weight of 6 because we've already added item 3. So what we got to do is take away 2 from it. 1, 2, and we'll just solve this right now. So now our pointer is on weight 4 with items 1 and 2. And we do the same thing. We check 9 the same as 7, no. So item 2 is going in the bag. Cross it out, and we move the weight 1. Now we're here. and then we would add 1 because it's not 0. Actually, in the code I didn't add 1 for 0 items, so we might run into a problem, but we'll deal with that when we get there. But okay, let's go code this out. Okay, so first thing we're going to need for the code is a list called packed, and we're going to add to this whenever we add to it. Okay, then we need a column pointer, and remember we started at the max weight, so we'll set it to max weight. Now we're going to do decrementing for loop, so we're going to start at item 4 and then work our way back. So row in start and we got to do -1, I think. What's this? Then we're gonna go there, and we're gonna go -1 each time. So this should, I'm gonna check if I'm doing it right. Row. Okay, so yeah, that worked. Okay, remember what we did was we checked at the row and the column if the one above it is the same. So let's do that. So if matrix row column, if it does not equal -1. And we won't actually do an else because we don't have to do anything about it, so this should be easy. So if it does not equal, that means it is in the weight, so we do packed search. Let's just do the index, so we're just going to put the item number. We won't keep track of the weight or the value, let's just keep it simple. And remember, we got to move our column pointer as far left as the weight of the item we're adding. So minus equals, so what's the weight of the row? So items, 0 is the weight, and at row. Okay, let's just print it out. Let's see if it adds item 1. No, so we did reach a problem. So it didn't add item 1. So there's probably a better way of fixing it up here, but if row equals 0, and what do we do? Matrix at row column. If this does not equal 0, then we'll just add insert row. This is kind of a hacky solution, so yeah, so that worked. And why don't we just print what do we do in the max value we're getting? So value max value is matrix at what do we do in like the length of the list, and our column will be max weight. I think so. Nope. Yeah, always with the off by 1 error. So max value is weight. Here's all the thing, and that is the knapsack problem. Okay, so thanks for watching.